the CPU and memory, and how the data is transmitted from output devices to from processor to output devices. Input operation is nothing but the data transmitted from input device like a keyboard, like that. The data is transmitted from input device to computer, the processor or memory unit. Here is nothing but input operation and output operation. The processor results which are available in the processor and memory. Input output organization, the fourth unit. How the input devices transmitted the data and how the output devices are received the data from the processor or memory. Okay, and different types of input devices and different types of output devices, how they are connected to the processor or memory or simply computer. How these devices are connected to the processor and how the data is transmitted from input device to processor or memory, or the results transmitted from processor or memory to output devices. Okay, without any input device or output devices, there is nothing to do in the processor. Okay, the nothing, because if you want to process any device or any operation, you have to give program. Okay, instructions are given to the processor. All of you mute yourself. Someone. Hello. Kavya? Kavya? Ishtija? And participants lo chudu ఎవరు మీ కౌంట్
62
చేస్తుంది?
sir.
62,
62 sir.
62. ఓకే ఓకే అమ్మా 62 62 462. Please mute yourself. Otherwise I will remove from you. The first topic is accessing IO devices. How the IO devices are accessed. Nothing but accessing data. How the data is accessed from input device. The processor is accessing the data from input device. The instructions and the data are given to the processor or memory from input device. The instructions, a group of instructions, nothing but program. Program are written by the user and these are entered into the processor through keyboard. Keyboard nothing but input device. Input device to the programs are transmitted to the processor or memory, and the data also received from the input devices like keyboard. That is accessing the instruction or programs and data from input device. And these programs and the data given by the user are processed by the processor. The results are shown to the user in a meaningful form, by using output devices. That's why the output devices are required. If you want to see the results, you have to use the monitor display unit. And if you want to listen the speakers, and if you want to permanent record, then you are using printers, like that. Different applications, different devices are there. These are output devices. The joystick, keyboard, these are input devices. And accessing IO devices, and with respect to processor, we are talking about with respect to processor. All of you mute yourself. There are a lot of disturbance. మళ్ళీ బ్యాక్ వచ్చి నేను మళ్ళీ రిమూవ్ చేసి టైం వేస్ట్ కదమ్మా. ప్లీజ్ మ్యూట్ యువర్ సెల్ఫ్. Accessing IoT devices, nothing but accessing data from input device and transferring data. That is result, processed results are transferred to the output devices. That's why we are talking about with respect to processor receiving the data from the input device and transferring the data to the output devices. This is commonly known as accessing IO devices. Okay, this is the block diagram for accessing the IO devices. The processor and memory. Whether if you want to execute any program, the program first stored in the memory unit. Okay, in consecutive location. If you want to execute any program, the program must be stored in the memory unit. The memory unit. First, the program is stored in the memory unit, and then the instructions are transmitted from memory to processor and executed by the processor. These are the bus. This is called the bus lines. The bus lines consist of 3 lines. What are they? The bus consists of 3 lines. What are they? Address line, control line, and the data line. The 3 lines. The bus is nothing but a group of lines. A group of wires is known as bus. Bus lines center. Bus lines center. It is a combination of lines. 3 lines: address line, control line, and data line. These 3 are combinedly known as bus lines. Okay. Make single line draw chesina, it consists of 3 lines. Okay. For simply drawing the diagram, we have shown just simply bus, but it consists of 3 lines: address line, control line, data line. These 3 lines are used to communicate with the IO devices. We have connected IO device 1 and IO and so on IO device 2. N. There are connected n number of devices. Okay, keyboard like that. This is keyboard and printer, monitor, speaker, like that. We have connected so many devices at a time to the processor or computer. Okay, that's why we have shown n number of devices. IO device 1 to IO device and so on IO device n. Okay, multiple IO devices may be connected to the processor and the memory via a bus. Okay, we have connected at the same time. At a time, we have connected so many multiple devices. Okay, we process computer at a time keyboard ichchestaru, at a time monitor and printer like that. Okay, all these are connected at a time. Very multiple devices are connected to the computer or memory through ports. Okay, and bus consists of 3 sets of lines to carry address, data, control signal. Okay, address, data, and control signals carry cheyadaniki we have 3 lines. Already discussed: address line, control line, data line. These 3 are used to carry the address signal, data signal, and control signals. To transmit these 3 types of signals, we have to use 3 lines: address line, data line, and control line. Okay, each IO device is assigned a unique address. For each device, we have assigned one unique address. For keyboard, we have assigned one address. For printer, we have assigned one address. And for monitor, we have assigned for each device, we have assigned one address. address keyboard 1001, and for monitor it is 1002, like that. And for printer it is 03, last two digits, like that. 10002 and 10003 and 1004, like that. For each device we have assigned one address. The addressing is given to the devices for easily communicated. So communicate చేసేటప్పుడు నువ్వు ఏ డివైస్ కమ్యూనికేట్ చేయాలనుకుంటున్నావో చెప్పాలి కాబట్టి we have assigned one address to the each device. Okay, and to access an IO device, the processor places the address on the address lines. Okay, to access any device, అంటే నువ్వు ఏ డివైస్ తో కమ్యూనికేట్ చేయాలనుకుంటున్నావో then that address is placed in the address line. The address line, okay, we have placed the data on the address on the address line. The device recognizes the address and responds to the control signal. The device recognizes the address. For each device, there is a decoder, address decoder is there. For each device, one address decoder, and the decoder decodes the address placed by the processor. That address placed by the processor, and if the address is matched, then the path is established between the device and the processor. And if the matching it does not occur, and these are open circuited. Okay, let us take the keyboard address is 1001. Let us take keyboard address is 1001. Then if the processor is wanted to communicate, the processor is wanted to communicate with keyboard. The processor is wanted to communicate with keyboard. Then the keyboard address of 10001 is placed on the address line. Bus lines lo 3 lines ఉంటాయి చూసారా, address line, data line and control line. These 3 lines, and the processor communicated with the keyboard device. Then the processor is placing the address of that device. And ఏ డివైస్ తో కమ్యూనికేట్ చేయాలనుకుంటుందో ఆ డివైస్ యొక్క అడ్రస్ ని ఇట్ ఈస్ ప్లేస్డ్ ఆన్ ది అడ్రస్ లైన్. అడ్రస్ లైన్ మీద ప్లేస్ చేస్తుంది. బస్ కన్సిస్ట్ ఆఫ్ 3 lines: address line, control line and data line. The device, the processor placing the address of the device on the address line, and that address is transmitted to the each device. That address is transmitted to the each device. ఆ అడ్రస్ అనేది ప్రతి డివైస్ యొక్క అడ్రస్ డికోడర్ కి వెళ్తుంది. ఈచ్ డివైస్ విల్ హ్యావ్ వన్ అడ్రస్ డికోడర్, and the processor sent the address is transferred to each device address decoder, and each device the address decoder ఏం చేస్తుందంటే the processor sent చేసిన అడ్రస్ ని డికోడ్ చేసుకుంటుంది. డికోడ్ చేసుకున్న తర్వాత అది 1001 పంపించింది కదా, ఆ అడ్రస్ ని డికోడ్ చేసుకుంటుంది. ఆ అడ్రస్ అనేది ఏ డివైస్ యొక్క అడ్రస్ కి మ్యాచ్ అవుతుందో then the path is established between that device, and remaining device are open circuited. అంటే there is no connection between remaining device with the processor. And physically the connection will be there, and the data is not transmitted to the remaining devices are in unmuted. Okay, like that, muted, and only the keyboard is transmitting the data. Okay, only the keyboard is transmitted the data, and the remaining device are in mute position, and keyboard is only transmitting the data to the processor. All remaining device are clear. Explain just a. The bus consists of three lines: address line, data line, control line. The processor is placing the address on the address line మీద place చేస్తుంది. That address is transmitted to the all the devices. For all the devices, that address is transmitted to all the devices, and the address decoder is decoding the data. Let us take 1001 is the address of keyboard. This keyboard address అనుకోండి. Now the processor is wanted to communicate with the keyboard. Then processor is placing the address of 10001 on the address line. That address is transmitted to the all the devices, and the address decoder decodes that address, and it is matched to the device address. Then a path is established between these two devices. That is processor and keyboard ki the path is established, and remaining devices are open circuited. Okay, the data is transmitted only to the keyboard device, received by the keyboard device, and remaining devices are all muted. This is establishing the connection between the required device, and ఏ డివైస్ తో అయితే కమ్యూనికేట్ చేయాలనుకుంటుందో ఆ డివైస్ తోటి ఫస్ట్ ఈ పాత్ ఎస్టాబ్లిష్ చేసుకుంటుంది. ఓకేనా, బై యూజింగ్ అడ్రస్ లైన్. బికాస్ ఫర్ ఈచ్ డివైస్, చెప్పమ్మా. హలో, ఏ ప్రాబ్లం? Hello, shall I continue?
Yes, sir.
Okay. First, the processor is establishing a path between the device, and ఏ డివైస్ తో కమ్యూనికేట్ చేయాలనుకుంటుందో ఆ డివైస్ తోటి the processor is establishing a path by using the address lines. Very clear? The bus lines లో ఉన్న 3 lines ఉంటాయి: address line, control line, data line. The address line is used to establish a path between the device and processor. Processor నుంచి device కి path establish చేయడానికి the address line యూజ్ చేసుకుంటుంది. ఓకేనా, this is establishing the path. Okay, next one. The IO devices and the memory may share the same address space. That nothing but in the previous slide we have given the address lines, the address to each device. Okay, the address are given to the each device. Distinct address are given to the separate different addresses are given to the each device, and the memory addresses, this is memory unit. డివైస్ కి అడ్రసింగ్ ఇవ్వడం అంటే ఏంటంటే నథింగ్ బట్ ఫర్ ఈచ్ డివైస్ వన్ డేటా ఇన్ రిజిస్టర్ ఈజ్ దేర్, వన్ డేటా రిజిస్టర్ ఈజ్ దేర్ ఫర్ ఈచ్ డివైస్, వన్ డేటా రిజిస్టర్ ఈజ్ దేర్ ఫర్ ఈచ్ డివైస్, వన్ డేటా ఇన్ అండ్ డేటా అవుట్. ఓకే, ఫర్ ఇన్పుట్ డివైస్ కి అయితే డేటా ఇన్ రిజిస్టర్ ఈజ్ దేర్, ఫర్ అవుట్పుట్ డివైసెస్ దెర్ ఈజ్ డేటా అవుట్ రిజిస్టర్ ఈజ్ దేర్. ఓకే, ప్రాసెసర్ ఇది ప్రింటర్, మానిటర్, వీటికి అయితే ద రిజిస్టర్ is called data out register అంటారు. whereas for input devices the register is known as data in register అంటారు. ఓకే, ఆల్రెడీ సెకండ్ యూనిట్ లో మీకు ఫిగర్ డ్రా చేసినప్పుడు చెప్పాను. ఎస్ ఇన్ ఫ్లాగ్, ఎస్ అవుట్ ఫ్లాగ్స్ ఉంటాయి, అండ్ డేటా ఇన్, డేటా అవుట్. డేటా ఇన్ అనేది ఇన్పుట్ డివైస్ యొక్క రిజిస్టర్, డేటా అవుట్ అంటే అవుట్పుట్ డివైస్ యొక్క రిజిస్టర్. ఓకే, అండ్ అడ్రసింగ్ is given nothing but we are giving the address to the register, data in register, and the memory address this is 0000 start అవుతుంది. like 32 bits, 32 memory words అనుకోండి. there are 5 bits are required to address the memory, 0000 and 00001 like that. And for data in, data out of keyboard device, that is 10001, 10002. this is the keyboard data in register and mouse data in register like that. That means the same, the address space for the memory unit as well as the device యొక్క రిజిస్టర్ యొక్క అడ్రస్ and the memory unit addresses are all combined. Okay, the same address space we have given the addresses to the both memory and IO devices. That's why the IO devices and memory may share the same address space. Space and this is different space and memory unit, the addresses are different, and the input output devices, the address space is different. This is memory address space. This is IO device address space. ఇక్కడ ఏంటంటే here the 0000 starting memory location, the same address may be given to one IO device. Okay, similarly here 10001, similarly 10001 may be possible to give the same address to the another data register. Okay, because both are different address space, whereas in memory mapped IO, memory addresses and IO devices address are in same address, single address space. Kabatti there is no chance for same address is given to both memory and data in register. Okay, address memory unit ki and data in register ki iche chance ఉండదు ఎక్కడ మెమరీ మ్యాప్ లో, because సేమ్ అడ్రస్ స్పేస్. వేరే IO మ్యాప్డ్ అంటే memory unit address space and IO device address space both are separate. Okay, both are separate, and there may be a possibility of the same address is given to memory unit as well as IO devices. Okay, that's why we are using memory mapped IO. In memory mapped IO, both are the same address space. That's why there is no chance for giving the same address to both memory unit. Similarly, for IO devices, there is no chance of giving same address to the memory unit as well as IO device. That is, the IO device address are separate and memory word address are separate. That is called memory mapped IO. Both memory unit and IO device are in same address space. That is called memory mapped IO. And IO mapped IO is also there. That is, both memory unit and IO devices are having different address space. And any machine instruction that can access memory can be used to transfer data to or from an IO device. And in memory mapped IO, what are the instructions to access the memory unit? మెమరీ యూనిట్ నుంచి డేటా రిసీవ్ చేసుకోవడానికి, అలాగే మెమరీ యూనిట్ కి డేటా ట్రాన్స్ఫర్ చేయడానికి రీడ్ ఇన్స్ట్రక్షన్, రైట్ ఇన్స్ట్రక్షన్ ఆర్ దేర్ టు యాక్సెస్ ద డేటా ఫ్రమ్ మెమరీ యూనిట్. మెమరీ యూనిట్ నుంచి యాక్సెస్ చేయడానికి అయితే మనం ఏ ఇన్స్ట్రక్షన్స్ అయితే వాడతామో ద సేమ్ ఇన్స్ట్రక్షన్స్ ఆర్ యూజ్డ్ ఫర్ IO ట్రాన్స్ఫర్ ఆల్సో. దట్ ఈస్ ఇన్పుట్ డివైస్ నుంచి డేటాను రిసీవ్ చేసుకోవడానికి, అలాగే అవుట్పుట్ డివైస్ కి డేటా పంపించడానికి కూడా the same instructions are used. What are the instructions used for memory unit? Memory unit కి అయితే మెమరీ యూనిట్ నుంచి యాక్సెస్ చేయడానికి అంటే రీడ్ ఆపరేషన్, మెమరీ నుంచి డేటా రిసీవ్ చేసుకోవడానికి చిన్న రైట్ ఆపరేషన్, మెమరీ యూనిట్ స్టోర్ చేయడానికి. What are the instructions used for accessing the memory unit? The same instructions are used for IO device. That is the second sentence meaning. Any machine instruction that can access memory, అంటే మెమరీని యాక్సెస్ చేయడానికి ఏ ఇన్స్ట్రక్షన్స్ అయితే వాడతామో కెన్ బి యూజ్డ్ టు ట్రాన్స్ఫర్ ద డేటా టు ఆర్ ఫ్రమ్ అన్ IO డివైస్. అంటే టు అంటే అవుట్పుట్ డివైస్, ఫ్రమ్ అంటే ఇన్పుట్ డివైస్. ఇన్పుట్ డివైస్ ని తీసుకోవడానికి, అవుట్పుట్ డివైస్ పంపించడానికి ద సేమ్ ఇన్స్ట్రక్షన్స్ ఆర్ యూజ్డ్ ఇన్ కేస్ ఆఫ్ memory mapped IO, because the addresses are different కాబట్టి we have used same instruction. And simpler software, same address space, then there is no matching of addresses కాబట్టి the software is very simple. IO device and the memory may have different address space. Okay, both are having different address space. Memory address space is different, IO input device address space is different. and there is a chance for the same address is given to both memory unit as well as IO device data registers. For this case, special instructions are given to transfer data to or from the IO device. Okay, ఇక్కడ ఏం చేస్తారంటే the instructions are separated. That is memory unit కి అయితే memory read అంటారు and memory write operation అంటారు. Whereas for IO instruction కి IO device కి అయితే IO read and IO write. The instructions are separated. Memory read, memory write. For IO devices, IO read, IO write. Whereas in memory mapped IO, in first case, same instructions are used for both memory and IO devices. In this case, memory instructions are separate, IO instructions are separate. Memory read, memory write. Similarly, IO read, IO write. To access the memory unit, you have to use memory read, memory write instructions with these two. Whereas to access IO devices, you have to use IO read, IO write instructions. IO device may have to deal with fewer address lines. IO address lines need not be physically separate from memory address lines and IO address lines. This is the clear-cut actual connection of devices to the processor with one device. Here you have device connected so many devices. The bus and address line, data line, control line చెప్పండి చూసారా, సేమ్ క్లియర్గా ఇక్కడ మీకు ఎలాబొరేటెడ్గా డ్రా చేసి చూపిస్తారు. Bus nothing but it consists of 3 lines: address line, data line, control line. These 3 are combinedly known as bus lines: address line, data line, and control lines. These 3 are combinedly known as bus lines. And for each device, this is only for one input device. And let us take, I taking a input device, keyboard. Similarly, there is another device. Then there is another device connected in a similar manner. There are so many devices are connected. N number of devices are connected. Just simply I have shown one device. Okay, elaborated one device, input device, and bus lines, address line, data line, and control line. For each device, IO interface. This is called IO interface, input-output interface. If you want to transmit the data from mobile phone to your computer, you have to use data cable. Data transfer చేయడానికి మెమొరీ మీ ప్రాసెసర్ నుంచి మీ కంప్యూటర్ నుంచి మొబైల్ ట్రాన్స్ఫర్ చేయాలన్నా ఆ మొబైల్ నుంచి మీ డేటాని కంప్యూటర్ కాపీ చేసుకోవాలనుకున్నా you connected the mobile to the computer by using a data cable. That data cable is nothing but it acts as the interface between your processor and your mobile. మీ మొబైల్ కి మీ ప్రాసెసర్ మీ కంప్యూటర్ కి మధ్యలో the data cable is acts as a interface circuit between your mobile and your processor, because your mobile speed is different, your computer speed is different, and your mobile data format is different, and your computer data format is different. Okay, and the speeds also different. The instructions and number of bits are also different. To synchronize all these, that means that the speeds and data formats and like that. To synchronize all these things, we have to use the data cable from mobile to processor, your computer, or your computer to processor. To transfer the data, you have to use the data cable, and that data cable is nothing but the interface circuit between your processor and your computer and your mobile. Similarly, if you want to communicate in IO device or in keyboard or a monitor or a printer circuit, and we had connected to the processor at the computer, And all IO devices, 99% all IO devices are electromechanical devices. Printer, keyboard, all these are electromechanical devices. All input output devices are electromechanical devices, whereas the processor and memory are electronic devices. Whereas the processor and memory are electronic devices. And there is a need for conversion of signals from electromechanical signals to electronic signals. There must be a need for conversion of signals. Similarly, all the IO devices, keyboard, printer, monitor, all these devices are all very, very, very slow devices compared to the processor. Compared to the processor, all the devices are very, very slow devices. Every device, keyboard, monitor, display unit, and printer, speaker, all these are all the IO devices compared to relatively very slow devices compared to the processor or computer. And the data formats and instruction formats, all these are differ from the processor data format. IO device యొక్క data format and processor device యొక్క IO data formats are all different. Okay, to synchronize all these conversion of signals and the speed difference between the device and the processor and the data formats are all different. To synchronize all these things, we have to use the interface circuit. The interface circuit. This is called the interface circuit. To interface the device, the input device to the processor. Processor ki connect cheyadaniki the input device, we have to use the interface circuit. The interface circuit is sometimes different from the IO device, or sometimes the interface circuits are inbuilt within the device. Interface circuits are inbuilt. Nowadays, all the interface circuits are inbuilt within the device, and some devices have the interface circuits outside the device. Okay, this is the interface circuits. Nowadays, the interface circuits are inbuilt within the device. And interface circuits consist of address decoder, control circuits, data and status registers. Address decoder, control circuits, data and status registers. Data and status registers, control circuits, address decoder. Already I have discussed address decoder, the function of address decoder. The IO device is connected to the bus using an IO interface circuit which has address decoder, control circuit, and data status register. These three are these three. Each interface circuit consists of three circuits: address decoder, control circuit, and data and status registers. Address decoder decodes the address based on the address lines, thus enabling the device to recognize its address. Already I have discussed it. For each device, one address is there, and that address is placed on the address line. This line. ప్రాసెసర్ అనేది ఏ డివైస్ తో కమ్యూనికేట్ చేయాలనుకుంటుందో ఆ డివైస్ యొక్క అడ్రస్ ని అడ్రస్ లైన్ ప్లేస్ చేస్తుంది. అండ్ దట్ అడ్రస్ ఈ ట్రాన్స్మిటెడ్ టు అడ్రస్ డికోడర్ ఆఫ్ ఆల్ ద డివైజెస్. ప్రతి డివైస్ యొక్క అడ్రస్ డికోడర్ కి వెళ్తుంది. We have shown only one device. Actually, we have connected so many devices, and that address is transferred to all the devices. Address decoder. మీరు ఆ ప్రాసెసర్కి ఎన్ని డివైస్ కనెక్ట్ చేశారో అన్ని డివైస్ యొక్క అడ్రస్ డికోడర్స్ కి ట్రాన్స్ఫర్ అవుతుంది. ఆ అడ్రస్ డికోడర్ ఏం చేస్తుంది? అడ్రస్ లైన్ మీద ఏ అడ్రస్ పెట్టారో ఆ అడ్రస్ ని డివైస్ యొక్క అడ్రస్ తోటి మ్యాచ్ చేస్తుంది. Let us take the processor is placing the address 10001 on the address line. Processor అనేది 10001 అడ్రస్ కలిగిన డివైస్ తోటి కమ్యూనికేట్ చేయాలనుకుందాం. Then the processor is placing the address on the address line 1001 is placed చేస్తుంది. And that address is transmitted to all the device address decoder. అన్ని డివైస్ యొక్క అడ్రస్ డికోడర్స్ కి ట్రాన్స్ఫర్ చేస్తుంది. ఏడి అంటే అడ్రస్ డికోడర్ అనుకోండి. ఫర్ ఆల్ ద డివైస్ అడ్రస్ డికోడర్ ద అడ్రస్ ఈ ట్రాన్స్ఫర్డ్. అండ్ దట్ అడ్రస్ డికోడర్ ఏం చేస్తుంది? ద ప్రాసెసర్ సెంటెడ్ అడ్రస్ and the device address both are compared. ప్రాసెసర్ సెండ్ చేసిన అడ్రస్ ని డివైస్ యొక్క అడ్రస్ తో కంపేర్ చేస్తుంది. ఇఫ్ దేర్ ఈజ్ ఎ మ్యాచ్ దెన్ the path is established between the device 1001, the address for the keyboard input device. Then this address and this address both are matched. Then a path is established between input device to and a path is established between input device to the data line and control lines. This is the address decoder decodes the address placed on the address lines, thus enabling the device to recognize the address. Okay, this is how the path is established between two device, the input device and the processor. Data register holds the data being transferred to or from the processor. The data register is used. The data register is used. It is here. The data register is used. The data register and status register are two registers are used for every device. The data register is used to hold the data transferred to or from the processor. అంటే డివైస్ నుంచి అవుట్పుట్ డివైస్ అనుకోండి, ప్రాసెసర్ నుంచి డేటా రిజిస్టర్ పంపించి the data registered to the device, the data is transmitted. If it is input device, the data from input device keyboard is transmitted to the data register, and from data register the data is transmitted to processor. That is data register. The data register holds the data being transferred to or from the processor. Status register holds the information necessary for the operation of the IO device. Status register. The status is nothing but whether the device is ready to transfer the data. అంటే the status of the device. Input device అయితే whether the device is ready to receive the data or whether the device is ready to accept the data. Input device అయితే whether it is ready to transfer the data. ఇన్పుట్ డివైస్ అనేది కీబోర్డ్ అనేది ట్రాన్స్ఫర్ చేయడానికి రెడీగా ఉందా లేదా. మరి అవుట్పుట్ డివైస్ అయితే ప్రాసెసర్ పంపించిన డివైస్ రిసీవ్ చేసుకోవడానికి రెడీగా ఉందా లేదా. ద స్టేటస్ ఆఫ్ ది డివైస్, వెదర్ ద డివైస్ ఈజ్ రెడీ టు యాక్సెప్ట్ ద డేటా ఆర్ వెదర్ ద డివైస్ ఈజ్ రెడీ టు రిసీవ్ ద డేటా, send the data. Okay, that is known by the processor through status register. Status register ద్వారా the status of the device is known by the processor, and data and status registers are connected in the data lines, and that information is connected to the processor by means of data line. Data and status registers connected to the data lines and have unique address. Already in the previous slide, addressing of IO device nothing but the data register addressing for IO data register. Okay, IO interface circuit coordinates IO transfer. The interface circuits coordinates the IO transfers. For all IO transfers are coordinated by the IO interface circuits. Okay, it is the interface between the processor and the input device or output device, anything. Okay, it is the interface circuits. These three are combined interface circuits. This is input device to transmit these three devices. The control circuits. The control circuits nothing but the control circuits are used for the control information sent to the device. Control information sent చేయడానికి you have to use the control signal. And then read operation or write operation. Input device we have to perform the read operation. అంటే input device keyboard ద్వారా read చేసుకుంటాం. అది read operation. Similarly for output devices, processor printer అనుకోండి, we have to send the data to the processor. Output device కి send చేస్తాం. That is write operation and read operation. Whether the data is read or write from the device, the read operation or write operation is placed on the control circuits. Control circuits are used to control the operation. The control circuits are used to control the operations. Okay, and address decoder to addressing the device, and data register to hold the data from input device to the data hold by data register and transfer to processor. Similarly, processor to data out register and then transfer to output devices. The status register, whether the device is ready to accept the data or whether the device is ready to receive the data, send the data. రిసీవ్ చేసుకోవడానికి సెండ్ చేయడానికి రెడీగా ఉందా లేదా. The status information is known by the processor through status registers. These three are combinedly IO interface circuits. Okay. And next class we have discussed about how the data is transmitted between the input device or output devices to processor. Okay. Thank you. One and all. Here attend తీసుకున్నామా. Here.
Yes, sir.
Okay. Thank
Yes,
you.
sir.
All of you submit assignment. Okay. Still 30 members have not submitted the assignment in Edmodo. Please submit the remaining students as early as possible. Okay. Thank you.